Hello, my friends. In my channel Math CNT, I would like to present an algebra course through a series of videos. These videos will exhibit the main concepts of algebra that you might need or use, along with math terms and a diversity of examples with complete solutions. So please, to see these lectures in this algebra course, check the playlist called Algebra Course Lectures. So I will present them as lectures: Lecture 1, Lecture 2, Lecture 3, Lecture 4, Lecture 5, etc. It might take not less than 55 lectures because they will be short ones on specific topic. So you can choose the topic you need, or you can see the whole course. It's up to you. So this is lecture 1 today. Now this video will be about lecture 1. It will cover real numbers. Next lecture will be lecture 2. It will cover fractions, LCD, and so on and so forth. Lecture 3 will cover sets. Let's start lecture 1 in algebra course. Real numbers. What is a real number? Everybody asks, what is a real number? A real number, I mean, it's a number that's real. So a number we can use in our daily life. It can be placed on the number line. See, in mathematics, we have something called number line. It runs from minus infinity until plus infinity. So this line, we call it number line. We can place all the numbers like this one here: 4.71, 2 over pi, 101, 0 over 15, etc. Real number can be positive, can be negative, can be 0. Also, real number can be rational here or irrational number, which I will explain in this video. What is a rational number and how do we know it's a rational number, and what is irrational number after a few minutes. Now let's look at subsets of real numbers. The simplest subset in the real numbers, we call it natural numbers. 1, 2, 3, 4, 5 until infinity. These are the easy numbers. Natural numbers, we can call them counting numbers. If you need to count number of students in the class, if you need to count number of pencils, number of trees, of chairs, you just use the numbers 1, 2, 3, 4. You don't use fractions. So these we call them natural numbers. Now whole numbers, the natural numbers along with 0. So if you put 0, 1, 2, 3, 4, we call them whole numbers. These are definitions you should know in the algebra and other math courses. Now, how about integers? What is integer? Integer is a number here, real number for sure, that are negative, 0, positive, no fractions. So when we say integer, see, this is the integers here: minus 3, minus 2, minus 1, minus 10, 0, 1, 2, 3, 4, etc. It goes from minus infinity to plus infinity, only the numbers with no fractions. 0 is not positive, is not negative. So we say the integers are the positive, there are positive integers, negative integers, and 0. Now let's move to rational. Rational numbers are the numbers that are integer divided by non-zero integer. So you should have an integer up, maybe 5, maybe 6, maybe 7, divided by non-zero integer. We cannot have 0 in the denominator because it will be undefined, which is not a real number. So the rational numbers are P over Q, where P and Q are integers and Q cannot be 0. Another way we can see rational numbers are decimal real numbers. See, we can have decimal real numbers here. decimal real numbers like 0.25. This number is terminating. That means finishing. There is no other decimals after 5. 0.25, which is 1 over 4. So every terminating decimal is rational, which we can write as fraction. Also, if the decimal is repeating, like 2.3333333, it's 2.3 dash, it is also rational number because we can write this decimal repeating as fraction. I will show you in this video also how to write any decimal repeating. Remember here, decimal repeating, you can write it as fraction, which is a rational number. Now, what is irrational number? Any decimal real number that is not rational. So first you check if the number, if I give you any number, you check if this number is rational or not. If it is rational, that means decimal repeating or decimal terminating. If it is not, it will be irrational. So the irrational numbers are decimals that are not repeating, not terminating. It cannot be written as a fraction, like pi over 4, square root of 3. You can see here some examples, minus square root of 17, minus 6 over pi, cube root of 2, pi itself. These are all irrational numbers. Now this is a little diagram to help you understand. See, the natural numbers are this small set inside. If you add 0 to natural, it will be a bigger set. We call it whole numbers. And then if you add the negatives, it will be integers. If you add the fractions, it will be rational. On the other side, there are irrationals. So we can conclude here that any real number is either rational or irrational. That's correct statement. Any real number is either rational or irrational. If somebody asks you about 0, 0 is here. 0 is rational number. 0 is rational number. It is a whole number. It is an integer. It is a rational and not irrational. Now let's see at example 1 here. Classify the natural numbers, whole numbers, integers, rational or irrational. I have big set here. Many numbers are there. I need to classify. You can pause the video and take 1 minute maybe to say which number belongs to which group. So minus 10.899 or 5 over pi, 0 over 17, etc., etc. So just try it yourself, and I will show you in the next slide the classification. All right. Now we have the same setup. I made a little table here, nice table. I put the natural numbers from the set, which is only 44. You see? The natural numbers. The whole numbers are, the 0 over 17 means 0, and then 44. So there are two numbers in the whole numbers, you can see clearly. The integers are 0, and there is minus square root of 36, which is minus 6, 44, and minus 10. So there are 4 numbers in the integer. Rational number, the first one, minus 10.899, it is terminating. You see terminating, minus 10.899. No other numbers after second 9. 0 over 17 is rational. Every integer here is inside the rationals. And also 3.14, you see that? 3.14, it's terminating. So that's rational. 1.121212, this is a repeating. So that's rational. 44 is rational. Minus 10 is rational. Now what are the irrational numbers? 5 over pi. See the second number here, ugly number. 5 over pi, and then 5.515253. It's not repeating. square root of half, and square root of 2. If you can simplify the square root, simplify it, then you can decide if it is rational or irrational, like minus square root of 36. I was able to simplify, it's minus 6. Nice question. Now, just a little definition about prime number and composite number. What is a prime number? Prime number is a positive number other than 1 that has factors itself and 1. So 2, what are the factors of 2? 2 can be divisible by 2 and 1. So that's prime, we call it prime. 3 is prime number. 5 is prime number. 7 is prime number. Why I did not put 8 here? 8 is not prime because 8 can be divisible by 2, can be divisible by 4, and 8 and 1. So it is composite number. So the 6 smallest prime numbers are 2, 3, 5, 7, 11, 13, and then you can try the other numbers. Composite number, positive integer greater than 1 that is not prime. So we start with 4, then 6, then 8, then 9, because 9 can be divisible by 3, 9, and 1. 10 is composite number, 12 is not prime. Okay, let's move now to the second idea here, convert the decimals to fractions. I will present many examples actually here. The first 3 are simple, x equals 0.5. If somebody asks you, give me the fraction that's equals to 0.5, so simple. Everybody will say half. Okay, I will show you how to get it if you don't know. Now, second number, y, 1.25, you see this is terminating, 2.021 terminating. So I need to convert these decimals to fractions. And be careful here, this example has no repeated part. The repeated part will be next example. Now, x equals 0.5. I know that 0.5 I can write as 0.5 over 1. See how many decimals after how many digits there? 0.5, 1 digit. So I multiply by 10 up and down. 0.5 times 10. Move the decimal point, it will be 5. 1 times 10 will be 10. Divide by 5, so you get half. See, that's so easy. You know it mentally that 0.5 is half. Now 1.25, little harder. Also 1.25 over 1, because we have 2 numbers after the decimal. Multiply by 100 up and down. So 125 over 100. Divide by 25, you get 5 over 4. 2.021, there are 3 numbers, but not repeated. Remember here, these numbers are not repeated. They are just terminating. So 2.021 over 1, multiply by 1,000, you will get this fraction. If you can simplify, simplify. Now let's move to repeated part. I have here 3 examples. Express each repeating decimal as a fraction. So 3.6666, we write it as 3.6 dash to make it easy, or 0.96 all dash, or 6.8 3 dash. See the last example C, I wrote here not easy. There is 6.8, 8 is not repeated, 3 only is repeated. I will explain the method. Let's start with, you can try yourself if you like, pause it a little and try A. Now, I have the number 3.66. Look at the method here. First, I say let x be 3.6666. Now, I ask myself, how many digits there in the repeated part? It's only one number, 6 repeated. So I multiply by 10 on both sides. So 10 times x is 10x. 10 times this, I move the decimal point to the right 1. So I get 36.6666. Now I take the second equation, 10x is equal to 36.6 dash minus the x. You see, second equation minus first equation. So 10x minus x is 9x. 36.6 dash minus 3.6 dash, I cancel all the repeated part. So 36 minus 3, 33. So now I have the number, if you divide by 9, x will be 33 over 9 divided by 3, you get 11 over 3. Now if you divide 11 over 3, you get 3.6666, etc. Now let's see the second one. Two repeated numbers, 0.969696, or we write 0.96 dash. Since I have two numbers in the repeated part, I multiply by 100. So 100 on both sides, 100x is equal 96.96, also repeated. I do the same thing, I mean, I subtract second equation minus the first equation. So 100x minus x will be 96.96 dash minus 0.96 dash. See, the repeated part will cancel. So I have 99x is equal to 96. So x will be 96 over 99 divided by 3. You get 32 over 33. Now let's take the difficult one, 6.8. I wish you could have tried this one. 6.83 dash. It's not easy. Now we'll go slowly, step by step. I have to get rid of the 8. You see this 8 here, it's not repeated. So I multiply by 10. Let x is equal 6.83 dash. So I multiply by 10. So I get 10x is equal 68.33333. Now forget about x. Concentrate on the 10x. Since I have repeated one number, I multiply 10x again by 10. You see, I will say it again. 10x is equal 68.333 repeated. Forget about x now. Multiply by 10, the second equation here. So 100x is equal 683.33. Now I have the same repeated part. You see the idea here, the trick? 100x minus 10x. I don't use the x in this example here. 100x minus 10x. Because the aim here is to cancel the repeated part. So 683 minus 68, which is 615. So x will be 615 divided by 90. Try to simplify it, divide by 5 up and down. So I get 123 divided by 18. Divide by 3 again up and down, you get 41 over 6. Look at this nice fraction, really nice. 41 over 6. If you divide that, you will get 6.833333, all repeated after that. Now, I would just want to highlight here, very important formula we use in division of two fractions. Very important in algebra, pre-calculus, calculus 1, calculus 2, or other math courses. If you divide two fractions, see, you can write it. You can write it like this. You can write it like this. You can write it like this. AB divided by C over D. Please be careful what do you do. Leave the first fraction, A over B, leave it, and then multiply by the reciprocal of C over D, which is D over C. So you invert the denominator, A over B times, instead of division, you put multiplication D over C, then you multiply AD divided by BC, and then you simplify. The last idea in this lecture one, in this video, will be about order of operations. I think everybody knows the steps, but you have to be careful how to apply them. So step one, if you have a fraction, work above with the numerator n and work below in the denominator of the fraction. Simplify each one separate. Then do any parentheses, square brackets, start from the innermost, from the inside. Step number 3, you apply all exponents and any power you have, and then the roots. Step 4 and 5 are easy and important. Step 4, you have to do the multiplications and division in the order in which they occur. From left, you have to work from left to right. So if you see two operations, multiplication, division, you have to start with the one on the left, from left to right. After you finish all the multiplications and divisions, you do all the additions and subtractions in the order which they occur from the left to right. I will give you here many examples to explain. Let's see. Find the value of each expression. 2 bracket 7 plus 2 cubed plus 4 divided by 2 divided by 3 times 5 plus 1. Please, in these questions, to learn more, you can pause the video for a minute and try it yourself on a piece of paper, and then you can check the answer in the next slide. You learn better. Okay. Now, check your answer, A, and also you can check B, and then we'll see that in each separate slide, I think. Now, let's go. So A, the answer is 2. If you get 2, then you are excellent in math. So look at here. We have to work in the numerator. There is a power here, 2 cubed. So 2 cubed is 8. And then inside the bracket, I should add here 7 and 8 before I do anything. Inside the bracket, 15. And then I have a division. 4 divided by 2 is 2 outside. Then there is a multiplication, you see. 2 times the 15 is 30, plus 2. Down, I have multiplication, so I multiply first, plus 1. 32 over 16 is 2. It's not difficult. There's a challenging question after a few minutes. Now, did you try B part, please? If you did not, if you want to try, you can pause it now and try it for a second. Maybe a little more difficult than part A. Okay, let's see now B. B, 24 divided by, so we leave that. Inside the bracket, we have 2 cubed times 5 minus 8 times 2. So I go to the power here. 2 cubed is 8, multiply by 5. So 40 minus, there is a multiplication here. I cannot subtract. I have to multiply first. 8 times 2 is 16. Now, down in the denominator, I have in the bracket 2 times 4, that's 8. 2 cubed also is 8. 8 plus 8, 16. So 9 minus 16 in the denominator. And then in the numerator, 40 minus 16 is 24. 24 divided by 24 is 1. And then we have a minus there. See, that's why I put minus 1 over 7. You can put 1 over minus 7. It's the same in math. You can take minus 1 over 7, 1 over minus 7, or minus on the line 1 over 7. These three are the same. Don't worry. Now look at this one. I called it here try at home. So you can try it. There are many other questions to try. Actually, when I do the lecture, I put some try at home. So try at home one, challenging question. In the try at home, I will give you only the answer. And then you can see in other videos, the detailed solution, detailed solutions. You can check order of operations. You can see other playlists. So evaluate this. Evaluate means find the value. Find the value of this expression. 9 divided by, in the bracket, first bracket, we have minus 5 squared plus 5 divided by another bracket, 7 minus 3 cubed divided by 6 divided by 3 minus 2 plus 0.04. Now, when you do all this, the answer is there. Only the answer. I hide the solution so that you can try yourself. So the answer will be 9/16. Believe it or not. Try it yourself. You can use this formula here. I tried to help you. Use this formula, division, A over B divided by C over D. It will be A over B times D over C, the reciprocal. Now, this topic, real numbers, it will be continued in lecture 2. If you want to see lecture 2, you can search for that in the playlist. Thank you for watching this video, and I hope I can see you in another video with another topic. So this is lecture 1. Thank you very much.